All right. Thank you, everyone. Thank you for taking the time to meeting with us. I am Tej Tenmatam, a Senior Solutions Engineer here at Cloudera. Today is a follow-up, actually, from the short overview session that I have done before about our company, Cloudera, as to what we do, why we do it, and how we do it. To recap, we are an enterprise data cloud company providing a 100% open platform that delivers multifunctional analytics for any data in any format on any infrastructure with consistent security and governance. So in today's session, I'm going to focus on a product within our data platform called Cloudera's Data Science Workbench. I'll be calling it CDSW going forward, so Cloudera's Data Science Workbench. So I'm going to cover why Cloudera created it and how it works. So if you look at it, right, so let's take a step back and look at some background about data science in enterprise environments today, right? Today, we are in a golden age of data science and machine learning. If you look at it, there are some bigger and richer data sets to work with than ever before. There are better and faster tools so that you can access them, query and process them. And at the same time, the cost of storage and computing continues to decrease. Whereas, I mean, if you look at the innovation that is happening, right, in the open source community around data science and machine learning, there are so many tools that are readily available that can be used on those huge big data sets. And even within business community, there is now a broad recognition that data science initiatives can be well worth the investment. Leaders do recognize that data science, it can create tremendous business value. However, I mean, if you go in an enterprise organization, big, large organizations, right? If you ask the data scientists, it does not feel like they are in a golden age of data science. The reason being that there are certain challenges in implementing data science initiatives. And sometimes, I mean, that can be kind of overwhelming. So let's look at, I mean, when I say overwhelming, right? So what are the pain points that they go through? So what is it that makes it difficult for data scientists in a big organization, right? So you can kind of bring it down to three main areas, right? So the first one, if you think about it, the scale, right? The data sets that they are working with these days are like too large to fit on a single computer. So essentially, I mean, you need a storage and processing that it must be distributed across a distributed multi-node cluster. But if you look at some of the tools and packages that data scientists that are most comfortable with, they do not run natively on the cluster, right? And then security, the next one. So in enterprise environments, data sets are stored on secure clusters. So configuring these client applications to authenticate to the cluster using Kerberos, if you are doing this manually, it can take a series of complicated configuration steps. And then what happens is that eventually it ends up with IT, and it kind of gets very difficult for IT to manage. They also struggle with requests coming from data scientists asking for, like, each data scientist is comfortable with a particular tool, right, or a package to be able to run it on the cluster. So that's a challenge, right? It's a burden for IT as well. The third difficulty, right, when it comes to the challenge is in collaboration. Many of the tools that data scientists use are comfortable using, right? They do not kind of facilitate collaboration and sharing. If you're working on a Jupyter notebook, I mean, if it is just 3 or 5 data scientists, maybe you could share across those Python notebooks. But once you cross like tens of or hundreds of data scientists sharing notebooks, that's not a feasible solution, right? So I mean, not only that, I mean, there is a lot of work. So if they are working on laptops, with their own different dependencies and versions, reproducibility is a big problem, right? Like, so that is another challenge that the data scientists face in an enterprise these days. So, I mean, the reality based on these, right? Uh, the data scientists, they end up struggling to achieve their goals. Instead of working on the cluster, these teams end up working mostly on laptops by taking a sample of the data, uh, and most of the work ends up gets done in isolation. And with that, I mean, if they are building multiple models, right, like the data science is an iterative process, right? So all of that insights and models are not broadly shared if they are working on their laptops. um, and there are obstacles setting up environments. It's not easily reproducible, and eventually what happens is that the data scientists find themselves stuck in like working in silos. It's not because that they are unwilling to share what they are working on, or unwilling to collaborate, but because the tools and environments that they have right now, it makes it very difficult for them to collaborate. And data science is, I mean, it is not it cannot be done in silos, right? Like, it is a team sport. From an idea to a minimum viable product, like for a deploy production model, there are many people, roles, and responsibilities, right? So it starts with a business analyst defining the problem, a data engineering who is working on discovering, collecting, cleaning the data, a data scientist who is working on feature engineering, doing the machine learning model building, right? And an ML engineer, machine learning engineer, productionizing it and managing it and monitoring those models, right? So if you all these different people with their different roles work together to productionize a machine learning model. It starts with an idea, it goes through the data wrangling, collection, cleaning, exploration, transformation, building a model, and then deploying a model, right? And it never ends with once you fit a model, that it never ends there. You always iterate on it. You tune the hyperparameters. You try different new, maybe you add new columns. You do different kinds of transformation, and then you iterate, and then this whole cycle goes on. So, so, so for this to work correctly, right? The goal for an enterprise data science is that they really want a platform that helps them overcome those struggles. The platform that they need it should eliminate the obstacles that I was talking about. It should enable data scientists so that they can easily connect to a secure cluster, right? They should be able to use their preferred tools and the packages that they are comfortable with without causing any security risk and without putting a burden on IT, right? And it should facilitate collaboration and sharing. And it should be possible for data scientists to work collaboratively within a project, and then without each one of them managing the project dependencies, right? So a platform that can provide that is the goal. So with that, let's look at what data science workbench can bring here, right? So Cloudera's data science workbench was built to overcome those struggles. It is an important part of our solution for enterprise data science. It enables this fast, secure, easy self-service data science and machine learning for enterprise environments. So the entire life cycle that I talked about, from research and development all the way to production, right? So whether it is that you are analyzing the data, whether you are building and training the models, to deploying them as an API, REST API, all of it can be done through this Cloudera's data science workbench, and all of this is browser-based. So essentially, I mean, Cloudera's data science workbench, it provides you this secure, collaborative self-service platform for your data science teams. So let me pause there for a second and see if you have any questions before I talk about the architecture.
Good from my side. This has been great. Let's keep going.
Cool. Awesome. So about the architecture, right? So CDSW, Cloudera's Data Science Workbench, it runs, to my right, you see this, whether it is a CDH or HDP cluster, right? it runs on a gateway node. So next to it, we call those as edge nodes. So on the front end, CDSW gives you a web application, but on the back end, right? So the runtime environment is so when you, as part of your data science team, you built your Python scripts or R script or a Spark script, right? So for those scripts to run, you need a runtime environment, and that runtime environment is provided by a Docker container. So the Docker, so when you create a session, right? So we create a Docker container for you. So those containers, orchestration of those containers is done by Kubernetes. So the Kubernetes engine is, so CDSW uses Kubernetes engine so that it can orchestrate the containers, okay? And if you look at to my right, I'm using a CDH and a HDB cluster. So this brings a very specific advantages, right? So let's say I started some workloads. There are certain workloads that maybe I can run on just these CDSW nodes itself, these worker nodes that are there. But then I also have the capability to push some of those workloads down into the cluster so that I can actually leverage this extended compute power that comes with the cluster itself. So essentially, I mean, think about it, right? Like you are bringing a data scientist into the data lake right now. And another cornerstone of this architecture is that like it is secured and governed by default. So essentially, right? Like when I do the demo, I will show you how easy is it for you to connect to using Kerberos credentials to authenticate yourself, right? So that you're connected to the cluster. So whatever the cluster provides in terms of, let's say, if you have Ranger enabled and for security and Atlas for governance, right? So all of that comes along with you. Kind of, I mean, it comes along because you're able to authenticate. Next up, again, going deeper into the architecture, right? So let's say, as I said, right, like we use Kubernetes as the orchestration engine for the container orchestration. So let's say I started with, when I set it up, I started with one master node and two worker nodes. So all of my containers, the Docker containers, they will run on the worker nodes. So let's say I started with maybe 10 CPUs available to the data scientists, and then maybe 50 gig of RAM. But my team has grown, and then I want to add more resources. All I have to do is set up a new worker node, and then your data scientists will start seeing those additional resources available to them. So it's highly scalable. It's very easy to scale this architecture as well. And then if you look at it, right, so another key aspect of CDSW is the support for GPUs. So if you think about it, right, so with the advancements in neural networks with deep learning, for them to run, they perform really bad on CPUs, and they perform amazingly on a GPU. But then, I mean, GPUs are very expensive. So what CDSW does is it lets you actually share GPU resources. So that data scientists can actually share those GPUs. So it provides you that real multi-tenancy for GPU. So I mean, if you are using frameworks such as TensorFlow, PyTorch, or I mean, there are TensorFlow as a new API called Keras. So Keras, right? So all of them, they need GPU resources for deep learning, and CDSW lets you use them easily. So essentially, I mean, that's the architecture. And any questions before I jump onto the demo?
All good.
All good? Cool. All right. So let's go to the demo now. So here is so when I log in, right? So this is when I created this. So I have a five VM. I created 5 virtual machines for this demo environment. So the first 3 VMs, I have the CDH cluster running, and on virtual machines 4 and 5, I have CDSW installed. So this is what I see when I log in, right? So I'm logged in as admin user. So the moment I log in, I'm presented with this dashboard. So as you can see within this dashboard, right? Like as a data scientist, when I log in, so I see that like my data CDSW administrator has created 2 VMs. He gave 7 vCPUs and 31 gigabytes of memory. So had I like if I had access to GPUs, they would actually show up here too. So right now I don't have any GPUs, so it does not show here. So as you can imagine, I mean, this could be like 50 CPUs, or it could be like 500 gig of RAM in an enterprise scale, right? So all of those resources are readily available to your data scientists. So they do not have to work on a laptop anymore. So all they had to do, nothing to install on their laptops. All they need is a browser access. They connect to this um, CDSW, and they have access to these resources. So one thing when I was talking about one of the requirements is collaboration, right? So right now I'm connected as this one admin user, but if I'm doing this in an enterprise, right? So first thing that I would do would be create a team. So here I created a team called CDSW training, right? So with this training, so let me go, so I can easily switch context as a user, or I can be part of a team. So in this case, let's go to the team project, right? So I'm connected to this team, and I can set the quotas as an admin user, but in this case, I'm not. But if I go to settings, right, like within my team, I can add members. I can add a different user and different levels of like I can give them a contributor, right, so that they can start coding, or I could just give them a viewing rights, or I could, if it's a DevOps person, maybe I would ops person, I would just give them an operator role, right? So CDSW brings that team capabilities, so that you have, like when I showed you, right, that you have your business analyst, you have your data scientist, you have ML engineer, and all those different roles, right? So you have a team concept here. You bring in with the kind of roles and responsibilities that you give them. So once I have done that, right? So again, the next step is as you can see, I have a couple of projects here. I have a census project and I have a CDSW training project. So let's create a new project, right? So when I create a new project, so this is like the major like building block of CDSW. So this is what you do first thing. So this is where all your project files are and everything gets stored. So let's call this you give a name, right? So first thing first, CDSW training 1. So if I give a name, I see that like there are 2 project visibilities here. One is private and one is public. So what does this mean, right? So this is very similar to what you would do normally in a Git repository, right? Like you can think of a project as a Git repository, right? So because you're going to save all your files inside this. So essentially, I mean, if I make this project private, so only if as you saw, right, like when I created a team, I can add collaborators. So only those collaborators can actually view this project and do anything inside that project. But then if I make it public, any user who has access to this data science workbench can view this project. However, they will not be able to edit or do anything. They only have view privileges. And if I add a particular user as a collaborator, then they will have the typical, they can edit it, upload, or do anything that you normally do. So initial setup. So I can start with a blank project, nothing, clean slate, right? So this is probably where you will start. But if you are learning CDSW, you want some help. So what we do is CDSW out of the box, we provide some templates. We provide a template for R. We provide templates for your Python language. So again, this is polyglot. This CDSW is polyglot. Multiple languages, we support them. So Spark, we support that, PySpark, and then Scala, right? So you could pick one of those out of the box templates that we provide, or you have an option to create your own template. And once I create my own template as a CDSW administrator, if I go to the admin, I have a settings page where I can actually upload a new template that as an administrator I create it, and then my team uses that as a template. Or another option is I can start from an existing project that was done before. So it was in a zip file. I can just unzip it and then start using it. And the last option, right? This is probably the most prevalent option that everyone in the enterprise uses, because everyone has I mean, whoever is coding, right? That they always have this version control, and Git is the kind of de facto, right? Whether it is on GitHub or on Bitbucket or any of those Git-based version control systems out there. So this is probably the first place that you would normally go. Um, so to get this, right, so let's say in my case, what I will do, so on my GitHub repository, right, so I have CDSW training. So all I have to do, right, so I just copy this link. I can use with SSH or HTTPS. I'm using SSH. So all I have to do, right, so copy that and then click create project. So the moment I do that, right, so whatever was inside my Git repository, I got this here. So including the README, the markup language, it's all there. The files are there. Everything are here. So this interface is very similar to Git, because that is what like we wanted. It was deliberate. We want that collaboration happening, right? So this is deliberate. So now that I have all my files here, right, my Python scripts and everything, I need a runtime environment. So for that, what I will do, I'll go to an existing environment, right? So that I created. So for me to create, start working, I need a runtime environment. So to create a runtime environment, there are multiple ways to do that. So the first one is the interactive shell. So I want to start coding, and I want my code to run. So I have a sample example data. I have this data set up here. It's a flights data set. So for this script for me to run, I need a runtime environment, right? So for that, what I will do, so I can create a start a new session. So what this is actually doing, right? So it is saying we provide out of the box a Docker image, okay? So the Docker image is nothing but it has Ubuntu operating system, and then it has a set of Python and R and Scala packages already installed on that Docker image. So I can start with this base image that we provide out of the box, or if you are interested, I actually created another image. So it is customizable. So I can actually create a new image based on this whatever we provide, right? So if I want to add additional packages, right? So let's say you are working on a time series data set, and then we do not provide forecast package in R, but all your data science team, all they do is forecasting using on time series data. So I need that package, right? So you need some kind of a configurability to what we already provide. So you can easily do that. It is a matter of 5 minutes to build a new Docker image so that you can easily use it. So I'm saying, okay, take that Docker image, and then what kind of a code is it? So whether it is, so right now this is a Python script, so I need a kernel, right? So for that, we provide Python 2, Python 3, R, and Scala. So Python 2 is sunset, I think January 1st of 2020. So you do have it for backward compatibility, but I'm assuming that all your code is going to be in Python going forward. So you could use Python 3, and then the engine profile, right? So that container that I'm asking it to create, I'm telling it, give it 1 CPUs and 2 gig of memory. Again, this is customizable. So this is the defaults that I have set, but as a CDSW administrator, I can create a new profile saying that 10 vCPUs, 40 gig, or whatever, right? So essentially, I mean, that's all there is. And then click launch session, and then it will create a session. So to save time, what I have done, I have already created a new session that is already running. And this is the script, right? Example.py. So essentially, I mean, if you are looking in the to my right, so as you can see, so the session is running. When the session is running, you see this green mark here. When it is building, you will see it as red, but right now it is green. That means it is running. So I could run commands, right, like directly on this. So if I do an ls, it says what's inside this folder, right? So again, whatever was in that file system that when I imported from my Git repository, I have everything and I can see those in here, right? So if I do, if I want to quickly check what are the, so I said that like you get lots of Python packages and R packages already installed. So I can see that in this, when I do a pip3 list, I can see that this container already has these packages. So I have the pandas data frame, I have SciPy, Seaborn, Matplotlib, and so on. But then if I'm working on something deep learning use cases, I don't have Keras API, or I don't even see TensorFlow, right? So if I want to install that, right? So it's as simple as pip3 install Keras, right? So it will go ahead and install the Keras inside that inside that container. Not only that, I can do all of this in the browser, but then we also give you full access to the terminal itself. So this particular container, right? So as I said, this container is running with the R version 3.5.1, Python 3, and whatever the Java version. But then if I want to quickly check the operating system, right? I can say lsb underscore release, I think it's A. So I'm running, as I said, we provide this Ubuntu operating system. I have full access to it. I have df I can see my file system, ls-ltr. I can see the files, everything. And other thing that I said, right? Like collaboration is very important. I have full access to the Git, right? So Git status, if I do that, so whatever changes I'm doing in my Python script, I can just do Git commit, and then it will just commit to my Git repository. Git commit -a. And then it will go ahead and submit I have to type something, made changes, right? And then it will go ahead and push, and then I just do git push, right? So it's as simple as that. So you have that collaboration that directly from within the Workbench. And then if I look at it, right? So let me quickly, I think I have 4:30. So any questions before? Am I going too fast? Is it all okay?
It's okay for me.
Awesome. Cool. So as you can see, right? So I mean, this I'm going to explain this Python script, right? So this is a very simple data set. Most R users would be familiar. It's called New York flights. So this is a data set that comes from 2013, widely available, publicly available. So every flight that has left and arrived from New York City airports, that is from JFK, EWR, and LaGuardia. So that's the flights.csv file. It has about, I think, 36,000 rows. So it has the flight information, which airline it is, what time it left, what was the departure delay, what was the arrival delay. So that data set, we're going to explore that data set as an example here, right? So as you can see, right, simple commands like, this is a container which has Python already installed. So you could pretty much do everything, right? So whether it is Markdown that I'm showing here, or, oh, one thing I totally forgot. So when I first logged in, right? So that connectivity to the secure cluster, right? So if I go here, settings, right? So go to settings, Hadoop authentication. So sign out and sign in. So I as a user, right? So all I had to do was that the security configuration. All I had to do was one simple username and password that I had to enter, and then now I have full access to the CDH cluster. So now if I go back to my session, right? So now that I'm authenticated, I could just take that whatever the CSV file. I mean, that CSV file was not a big file. It's only 30 meg. But imagine if it were like to be a 50 to maybe 10 terabytes of data set, right? So I mean, which is not uncommon these days. So all I have to do, I have the same capabilities. I can just do HDFS, DFS commands, right? So now that I'm authenticated, I can just put that file into the Hadoop cluster. And then once I have done that, right? So Spark is amazing when you are dealing with big data sets, right? So again, the way you connect to the Spark is, I mean, as you can see, I just have to import the Spark session. And then here I'm saying that master is yarn. So when I say master yarn, that means that the Spark session is going to run it on the Hadoop, on the CDH cluster. Um, Otherwise, I mean, I have an option. If I say local, what it will do is it will start the Spark session inside this container. But I mean, I have access to the cluster itself. Why do I want to? Small workloads, maybe it's okay to do it on local, but I chose to do it, run it on yarn. Right. Once I have that, all I have to do is, I mean, I'm doing. I'm going to quickly glance through this. So I'm reading the data. I'm inspecting the data, and any transformations. So from that flights data set, right? So any transformations that I have to do, so I'm doing that. Spark also has something called. I mean, you have Spark SQL that lets you do SQL queries, right? So in this case, I'm saying, okay, what were the different airlines, how many number of departures, and what was the departure delay, right? So simple SQL query, I could use that. And then if it comes to visualizing the data, right? As I said, like out of the box, we provide matplotlib as a package installed. So here, what I'm doing is that I'm seeing if there is any kind of a linear correlation between departure delay and arrival delay. I mean, we know that like that there obviously would be some kind of relation, right? So as you can see, I mean, it says that clearly says that there is a linear relation between departure delay and arrival delay. Once I have that, right, some after visualization, that's what you do as part of this data cleaning, data transformation, and visualization. Once you have that, so you have some inclination. This is all part of exploratory data analysis. So once I have done that, then Spark provides you this machine learning library, MLlib. So I can run many different kinds of machine learning algorithms out there, right? So one simple one that for this demo I'm going to use, I mean, since we saw that there is a linear correlation, let's fit a linear regression, right? Let's fit a linear regression and see how good is that that dependency, right? That linear correlation between departure delay and arrival delay. And that's what I'm doing here. So I have fit train and test. I split it into 70 and 30. And then I did a linear regression model, did a fit, and then I found that I had a intercept of almost 5.9, so that's about 6, right? 6 minutes. So essentially, I mean, that what this is telling is that if flights that departed on time kind of average, they came 6 minutes early, and that's what this linear model is telling me. And the slope it is saying that it is about 1. Which means that 1 minute of departure delay linearly correlates to just about 1 additional minute of arrival delay. I mean, that's what based on the data set I have, that's what my linear model is telling me, okay? When you are working with linear regression, the most frequent, like one metric that everyone uses, right, is the R squared. So I ran a query that says that, okay, my R square in this case is 0.84. The closer it is to 1, the better the accuracy is, right? So 0.84 is great. So that means that 84% of the variability that you see in this data set, in this arrival delay, is explained by that linear model. So, I mean, all of this I have done, I mean, the simple Python a linear model, right, that explains. And once I am done with this, I can do a Spark stop, and then it will stop the Spark session. And if I ever wanted to see what's happening, right, I have access to the cluster itself. I can see the yarn. So if I go to the yarn history, it will show the Spark job that it is running with all the metrics that you need to see. You can see that. So I mean, that's quickly about a session that I'm running. I have 2 other things here. So 4:36, I have another 10 minutes. So what I will do, I will explain experiments and models and jobs, and then I'll stop for any questions that you might have. So as I said, right, like when you are working, I mean, interactive session is fine, but when as a machine learning engineer, right, so and a data scientist, what they do is, I mean, they experiment with many. I mean, once you fit a model, the same the flights data set that I was talking about, just fitting one time is never enough, right? Like you want to get a better outcome for your model. So you test different things, and experiments is what you use it for. So essentially the same script that I was running in terms of identifying the accuracy, the R squared that I was talking about, what if I run an experiment, that same script that I ran before, but run it with intercept turned on, the argument intercept on, true, turn to true, and one without an intercept. And this is my R squared results, right? So 0.8373 and 0.82. So clearly, this 0.83 is better, right? So you want to use this model. So you want an intercept to be on. So, I mean, again, if I have to show you how to run an experiment, right? So all you have to do is show it where the script is located. So I can just go to the experiments, experiment.py, and arguments, true or false, and the engine kernel, and again, engine profile, right? So how many, what is your container shape, right? So how many vCPUs and how much memory. So that's how you run experiments. And clearly, I can see that in this case, for this particular model, intercept to turn to true is what I want. So once I have decided that, right, okay, this is what I want to do, then you come and create a model. A model is again the same thing, right? Like I'm running a new script, pretty much saying that, okay, given, so if I give you the scheduled arrival time, so let's say let's say Delta Airlines, it is supposed to come at 15:45. That's my scheduled arrival time, but that flight started maybe 15 minutes late. There was a departure delay. I want this model to predict what would be my arrival time based on that 36,000 rows of data set that I had, right? I created a model. I want you to predict what's the the time that it would arrive, and it will tell me that, okay, it's going to come at 15:54. Okay, 15:45 was the scheduled arrival time. Because there was a delay, it's going to arrive at 15:54. So this model creation itself, right? Like it was so simple, right? All I had to do is give this file model.py, and I have a function there. So if I look at the script itself, right? So I have a function here, predict arrival time, given schedule arrival time and departure delay, return prediction arrival time. Based on what I have decided, I have done my experiments, and this is my code, right? So and when I deployed it, right, this model itself, I can set a replica set, right? So now this, let's say that I'm going to put this in a production, right? In a production environment. So for my client applications are going to use this model. So if I deploy this, right? If I say I want this deployed to 5 different replicas, a replica is nothing but a container. So there will be, what it will do is it will create 5 containers for you, and then the client applications are accessing this model, it will load balance it for you automatically underneath the hood. So that so one particular container is not overloaded. So all of this, all I had to do this was select the script, the function, in a JSON format, the input, and in a JSON format, the output, and then click deploy model. So it will go ahead and create this and create a REST API for you. I mean, imagine the productivity gains, like in a DevOps world. I mean, this is phenomenal, right? So you are able to do this, and then we give you this again. So if I want to quickly test this, right? So if I can test this in a curl. So if I have Postman, I can just test this. Okay, this is my model. This is my access key, right? When you're posting something as a REST API, you want to be able to secure, right? So there is an access key, and I can quickly change that access key. So for security reasons, I mean, it's as simple as this: regenerate, and then it creates a new key for you. So that it's always secure. And deployments, right? And then settings. So we looked at it. So that's experiments, and that's models. And finally, looking at jobs, right? again, I mean, you might have a monthly batch jobs, right? So this is when you are thinking about, okay, there might be some jobs that needs to run every month or weekly or something like that, right? So again, you give a script name, how you want to schedule manually. You want it to be recurring every 5 minutes or every few hours, or you could actually create a pipeline, right? So this particular script will depend on something else. So all of that can be done, again, engine profile and who needs to be reported, right? If you want to send a report, you can also do that. So applications is something that, okay, I have built my model and I want to quickly build like a web application, right? So that a Flask-based web application, I can quickly do that here as well. So essentially, that is CDSW demo. I do have two slides I wanted to show before I take your questions. So when I started, right, so I asked, so there were certain goals that I was talking about. So there was a goal that, like, a platform that gives your data scientists access to the secure cluster. So that was a blank then, now it's a check mark. Yes, you have access, direct access to your secure cluster. We have eliminated this complex security configuration. All I had to do was give the Kerberos credentials, right? Check mark there. Self-service, I can easily create my containers. Inherently, these are Docker containers running on Kubernetes. So that means this is the de facto standard in the world, IT world right now. So the isolation, right, that the containers provides you that isolation. The Kubernetes has a concept called namespaces. So they are always isolated. So you are not running into each other's workloads. Collaboration. So I showed you how easy it was to collaborate, creating teams, how you could use Git from within CDSW. You could push the code directly into your Git repositories and allow users to share projects. Yes, you can easily do that, right? So that's a check mark. All of this can be done now. So finally, I mean, this is my last deck. Always when we talk about the business case, right? So why should you invest in a data science workbench? The ROI is always in an enterprise when you are doing this. It always comes down to the 5 S's, right? The speed, stability, scalability, savings, and security. So you saw that the speed with which I could actually, as a data scientist, right, I could easily stand up the containers. I could easily set up a team environment. I could build and deploy an application, a model with a REST API, right? With just few clicks, and the platform was able to do that. So speed, that's what CDSW provides you. When it comes to stability, right? So as I said, like we have our CDSW uses Kubernetes as the orchestration engine, and inherently Kubernetes has 4 levels of high availability. If a container goes down, right? So there is a Kubernetes master node that will take care of immediately. It notices a container going down, it will bring up a new one. If a process within the container goes down, Kubernetes handles that. So you can set it up in a HA environment, right? So if one availability zone goes down, your platform is still running. So 4 levels of high availability the platform provides you. And then the third is the scalability, right? So you can start with maybe, let's say, 3 VMs, and it's easily scalable, right? Like without disrupting your anything, right? So it's you can add new virtual machines so that, like, you could give more resources to your data scientists. So easily scalable. And savings is not just about software savings, right? So there was tremendous opportunity here for your data scientists to be very productive, right? The time savings, the savings in terms of how easily they could bring up their models, and also for IT, right? So ops, like your ops team, the savings that that will provide. So all of this, when you are calculating ROI, right? All of this comes in. And last but not least, like everything that in an enterprise ties down to security. And security, as I said, I mean, it was authenticating to a Kerberos-based cluster. It was as simple as providing a username and password. So essentially, I mean, if your cluster has Ranger and Atlas, right? So you inherently you are getting all of those the security as well as governance. With that, let me. So I have about 13 minutes for any questions.
I don't have any questions.
Tej, I think that's really good. Go ahead and hit stop recording.
Cool.